Good day, viewers. Good day. Okay, I just want to revise with you this question. So this is the question that you want to answer. Okay. So the table C21 shows data collected from an experiment to determine the resistance of a conductor. There we have been given the table. This is the table showing the voltage and also current. Then the first one, plot a graph of voltage against current. So we'll be answering one at a time. Okay. So having this, and here what we are going to do is this. So I want to plot. So first thing, let's divide this graph. So what we have here, it's this line there, we call this as what? The vertical one, and this one is horizontal. So in a vertical, we are going to put voltage, and horizontal you put what? You put current. So now when dividing, the issue is just on dividing. So when dividing this, you put there, let's say you count. If I told there you put 0, you consider first the least value that you have been given and the highest. So if I told here I put 0, this side is going to be 10, the other is going to be what? 20, so on and so forth. So we are saying that 2 centimeters is going to represent 10 units. So 2 centimeters will represent 10 units. So here when you count these small ones, there you've got 1, 2, 3, 4, up to 10. Yes, somewhere there. Then so when you say 0, there's, we'll say, if this is 0, we're saying that there is going to be what? 0. Then like this. Then there's going to be what? 10. Then there's going to be what? 20. Then 30. Then up to what? So here it's up to 80. So you just give an allowance maybe up to 90. Yes. Then this side you have 0. It is the least number, and the highest number is what? 12. So there you say 2 centimeters to represent 2 units. So here we'll say 2. Then there we'll say 4. And then 6. Then 8. And then 10. 12. 14. Yes. So that's how we are going to do it. So now when plotting this, you start 0, 0, is here. This is where 0, 0 is. So you do like that. Then the second one is 4. So 0, 0. Then 2, 4. So 2 is there, 4. So you count there. There we'll say 2, 4. So 4 is there. There 2. 4 is there. So 4 is going to be here. So it will be like that. So that is 2, 4. Then in the second one, it's 4, 10. So 4 here, 10 is there. So you put your 10. Then there are 6, 16. So here is your 10. So 16, 12, 14, 16 is there. Then we also go to 8. There are 8, 26. So 8 is there. 26, 26, 8, 26. So 8,26, so 20 is there, your 22, 24, 26, it will be there. So your curve will look like this. It's going to form, no, the line that you are going to form, it will be what? A curve. So you are going to produce a curve. So this is the curve that has been produced. So this is how you are going to draw the curve. So this is the curve, and this is what has been drawn from this information. So from this information, we've plotted this curve. So this is the graph, which is voltage against what? Current. Voltage against what? Current. So this is what we've obtained. So just plotting this, you've got 4 marks. This one, 4 marks there, 4 marks, which means it's done. You get that on a silver platter just by dividing the graph and also knowing on how to plot. Now the second one, use the graph to estimate the resistance when the current is 5A. So where your current is here. So now you want to determine your resistance. So remember the formula for resistance. We know when you are calculating the voltage, we say this one is V is equal to IR. So resistance we divide by I, even there by what? I. So R is going to be voltage over current. So what is your resistance? So you go on the graph. There is 4. So in between there, that is where the 5 is. So you count 1, 2, 3, 4, 5. So there is your 5. So your resistor, you just pick, you draw using your pencil and the ruler. So you do like this. So where this curve, this line meets the curve, then you do like this. So you pick your voltage there. So this is your volt. So if this is 12, so it 11, 12, 13. So your voltage there is what? 13. Then the question is, what use the graph to determine the resistance. So you calculate. You calculate. So you say R is equal to 13 over 5. So how many times can 5 go into 13? So R is equal to 5 into 13, it's 2. Remember 3 there is point, then you add 0. Then there is what? 6. So resistance is what? Ohm. So you are done just like that. So just use a graph to answer B. This is B to answer B to max. So that's all. Then just considering the graph, how your graph has come out. So this is the graph. And then the question C1, does the conductor obey Ohm's law? So here, remember Ohm's law, we say this one has to be direct proportion to voltage. So current should be direct proportion to voltage. So now having this, which means this one does not obey Ohm's law. So here we are saying that it does not obey Ohm's law. So does the conductor obey Ohm's law? So your answer is no. There, C1, your answer is what? No. So your answer, just write no as your answer, no. That's so C1. So you say it's what? No, it does not obey Ohm's law. Justify your answer. So to justify your answer, you say because the current is not direct proportion to voltage. So we are saying that C2, to justify our answer, we'll say current. So because current is not direct proportion direct proportion to voltage. So that's the answer. Then C or G, what term is used to describe such type of conductor? So any conductor that which does not follow Hooke's law, or sorry, which does not follow Ohm's law, we call this as non-ohmic conductors. Non-ohmic conductors. So G there I see non-ohmic, from the word ohm, I should just say ohmic conductors. Non-ohmic conductors. So that's the answer. Then the last one there, give an example of conductor that do not. Give an example of a conductor that behaves like this. So these examples of conductors that behave like this, we've got, you know, the name is semiconductors. So under these semiconductors, we've got you know, silicon. They do behave like that. Thermostat, they do behave like that. Then even in the filament lamps. So an example, they want an example of these semiconductors. You just say filament lamp. Okay, filament lamp. So if you want, you put now in this bracket, you say semiconductors. So these are semiconductors, and these semiconductors does not obey Hooke's law. Thank you very much. If any question, please do as usual.